On a clear night, when you look up at the sky, you see thousands of stars shimmering above you. Yet the star closest to us is not among them. That star is Proxima Centauri, a faint red dwarf in the constellation Centaurus. It is 4.24 light-years away. That number sounds small, like a neighbor living just next door. But a light-year is a unit designed to deceive human intuition. Light travels about 9.5 trillion kilometers in a single year, which means this neighbor is actually more than 40 trillion kilometers away. That number is too abstract for the human brain to truly grasp. So let's make it concrete. If you drove a car at 100 kilometers per hour, non-stop, without ever resting, it would take you more than 45 million years to arrive. That is longer than the entire recorded history of human civilization combined. The closeness we often speak of is nothing more than an illusion created by astronomical numbers. In reality, 40 trillion kilometers is a chasm that cannot be bridged by conventional means. Even the most accessible star lies in a realm of hopeless distance compared to our navigational capabilities. We often take pride in our high-speed machines. The Parker Solar Probe is the fastest human-made object in history. As it approaches the Sun, it reaches speeds exceeding 700,000 kilometers per hour. This is an extraordinary engineering achievement. And yet, even at this staggering speed, it would still take roughly 6,300 years to reach Proxima Centauri. That span of time exceeds the entire recorded history of human civilization. A more familiar example is Voyager 1. Launched in 1977, it is now leaving the solar system at a speed of about 61,000 kilometers per hour. If it were heading toward Proxima Centauri, it would take more than 73,000 years to arrive. On a cosmic scale, our most ambitious spacecraft are moving at the pace of snails. To complete the journey within a single human lifetime, we would need to reach at least 10 to 20% of the speed of light. But at present, the sheer distance of 40 trillion kilometers renders all human speed records meaningless. Distance can only be conquered if we move fast enough. And this is where the laws of physics become an unyielding wall. The problem lies in the rocket equation. To accelerate, a spacecraft must carry fuel. Fuel has mass, which requires even more fuel to push that mass. This creates a vicious cycle in which the spacecraft's size grows exponentially. Even bold concepts like nuclear propulsion run into this barrier. To accelerate a medium-sized spacecraft to just 10% of the speed of light would require an amount of energy comparable to the total consumption of an entire nation over many years. And that is only the energy needed to accelerate. It does not include the equally enormous energy required to slow down at the destination. Beyond that, special relativity imposes an absolute limit. The closer an object gets to the speed of light, the more its effective mass increases. The energy required to gain even a tiny additional increase in speed approaches infinity. The universe does not allow shortcuts, no matter how advanced our technology becomes. Let us assume, for a moment, that we have somehow overcome the energy problem. Let us assume the spacecraft has reached a speed fast enough to arrive within a human lifetime. At that moment, we would encounter another brutal truth. Interstellar space is not empty, despite its name. It is a vast killing field filled with invisible traps. To the naked eye, space appears black and still. In reality, it is a chaotic and hostile material environment. Interstellar space is filled with gas, cosmic dust, and drifting microscopic particles at the speeds of our current spacecraft. These particles are harmless. They strike the hull gently, like raindrops on a roof. But at relativistic speeds, everything changes. Kinetic energy scales with the square of velocity. At 20% of the speed of light, collision physics becomes violently extreme. A dust grain the size of a grain of sand is no longer just sand. It carries the energy of an exploding hand grenade upon impact, and the spacecraft would not glide smoothly through space. It would be relentlessly bombarded by billions of microscopic bullets throughout the journey. No matter how strong the hull, it would be eroded layer by layer, continuously for decades. And all it would take is a single object, slightly larger, the size of a small pebble, striking head-on. The energy released would rival that of a tactical nuclear explosion. It would tear the spacecraft apart and instantly annihilate all life inside. Avoidance is impossible. At such speeds, sensors cannot detect obstacles early enough, and even if they could, the steering systems would not have time to react. The spacecraft would fly like a blind bullet, surrendering its fate to statistical probability. But physical matter is not the only enemy. The greater threat is invisible: radiation. On Earth, we are shielded by a thick atmosphere and a powerful magnetic field. Once we leave the solar system, that protection vanishes entirely. The spacecraft would be exposed to high-energy cosmic rays arriving from all directions in the galaxy. High-speed protons would pass through the hull as if it were made of paper. They would bombard the molecular structure of every material. Plastics would become brittle and crumble. Metals would fatigue and fracture. Delicate electronic circuits would be disrupted and fail beyond repair. For biological bodies, this is a slow death sentence. Ionizing radiation would destroy DNA in every cell. Not a disease to be cured, but disintegration at the genetic level. To block this radiation, the spacecraft would need meters-thick layers of lead, which once again brings us back to the unsolvable problem of mass. 2. Add shielding. Add weight. 2. Add weight, and the spacecraft can no longer move. Finally, there is absolute informational isolation. Distance creates a wall of silence that cannot be penetrated. Even radio waves, our fastest means of communication, are limited by the speed of light. If the spacecraft encounters trouble near Proxima Centauri, a distress signal would take over 4 years to reach Earth. The reply would take another 4 years to return. 8 years for a single exchange. There is no real-time assistance, no guidance from mission control, no comfort from home. The crew would be completely alone in the infinite dark, surrounded by dust, radiation, and silence. Interstellar space is not a highway to the stars. It is a grinding machine that crushes any biological ambition that tries to cross its boundary. Anything that attempts to move quickly through this realm pays for it with physical destruction. We can draw beautiful spacecraft on paper, but the universe has its own ways of rejecting human presence. The hostility of space is absolute, and it makes no exceptions. Many argue that if we cannot travel fast, we can choose to travel slowly. This idea leads to the concept of generation ships, enormous flying cities designed to sustain life for centuries, even millennia. The basic premise is simple: the people who depart will never arrive. They will give birth, grow old, and die aboard the ship. It will be their descendants, the 10th or 20th generation, who finally set foot on a new world. In theory, this seems like the only viable solution to defeat distance, but in reality, it is the most brutal and impractical idea of all, because it bets everything on the most unstable variable in the universe: humans. First, biology. A generation ship must be a perfectly closed ecosystem. Water, air, and nutrients must be recycled at 100% efficiency for thousands of years. The laws of thermodynamics tell us this is impossible. Entropy and decay are inevitable. One failed harvest due to mold. One air filter that breaks and cannot be repaired. One mutated virus in a sealed environment. That is enough to doom the entire population, with no escape. But technical collapse is not as terrifying as social collapse. Imagine the lives of those born mid-journey. They are born inside a metal box, drifting through nothingness. They never see a blue sky. They never feel real wind or real rain. They are prisoners of a dream they never chose. Their ancestors chose to leave. They are the ones forced to live with that decision. They are stripped of the freedom to determine their own fate. reduced to biological tools, caretakers of a machine, existing only to pass genes forward. The human mind is not designed to endure this kind of existential pressure. Claustrophobic confinement breeds psychological and behavioral distortions. Conflict becomes inevitable. On Earth, when disagreements arise, we can leave. We can move elsewhere. On that ship, there is nowhere to escape. A civil war in confined space would end the entire mission. Human history has never recorded a society that maintained perfect stability for hundreds of years without change or conflict. Over centuries, the original purpose of the journey may be forgotten or distorted. Proxima Centauri could become an abstract idea, a religious myth, or even a curse. Future generations might choose to turn back, or worse, sabotage the control systems in despair. The human factor is the weakest link, causing the interstellar dream to collapse from within. We are biological creatures, evolved to live on Earth's surface, bound to gravity, atmosphere, and natural planetary cycles. Trying to uproot humans from that environment and lock them inside an eternal metal box is an act against nature itself. And so, the final truth we must accept is clear. Proxima Centauri remains out of reach. The distance is too vast, the physical barriers too high, and our biological limits too fragile. We will not set foot there in any future we can realistically foresee. But this helplessness does not diminish our value. It simply redefines humanity's place in the universe. We are not conquerors, we are observers. Science has given us another way to touch the stars without moving our bodies. Light. With instruments like the James Webb Space Telescope and future generations of colossal observatories, we can peer into the atmospheres of distant planets. We can analyze chemical compositions, measure temperatures, and search for signs of life from tens of light years away. We can understand the universe without physically occupying it. There is a deep humility in this realization. The universe is vast and indifferent to our ambitions. It owes us no shortcuts. It owes us no new homes. The stars are there to be observed, not owned. Proxima Centauri will continue to glow faintly red for billions of years. It will remain a neighbor we can never visit, a reminder that no matter how far human intelligence can reach, our feet must still stand on the ground. We belong to Earth, and perhaps that is the only place we truly belong. Thank you for listening. I am Sao Hoa. See you next time.